So light focus is...
Now I will ask the question a little more explicitly. What is the color of this laser? Red color. That much you know, right? This color is always easier to find out. Red color. Fine. How do you get this red color? Anyone can get up and tell me what is this? Otherwise, I will ask a question: what is the material from which this light is coming? Radiated photon is a light, yeah. What is the material from which? I am talking science. This I am talking, yeah. This is coming from my mouth. And this is the material from which the laser is coming. What is the material, do you think? The end of Purul. Dila Purula. Very good. Solid laser. That is the material.
Some metal.
Some metal. It is basically a semiconductor laser. It's not silicon. The semiconductor laser, you have to find out that. It's a semiconductor laser. We are using it. I'm going to give you that also. You can have a gaseous ionization. You can have a detectors out of this. I want to detect light. The best detector, everybody has a mobile these days. And you have a nice camera behind this mobile. What is this camera is made up of?
Lens.
Lens. Okay?
Light sensing.
Light sensing.
Means captures light and makes a photo.
Light? Sensor. We call it sensor. Detector otherwise. What is the detector? We also have sensors. You touch, you have a sensing motion, sensing action. Now, camera is a mobile camera. What is it made up of? Photons. Photon sensor. It's a light sensor. Okay, fine. But what is it made up of? எங்கேயோ போயிட்டோம். நமக்கு முகத்தில் அழகான 2 கண்ணு இருக்கு. அந்த 2 கண்ணு டிடெக்டர் தான். இல்லையா? அது என்ன பொருளால உருவாக்கப்பட்டது? இது நீங்களே நானா உருவாக்குனதல்ல. கடவுள் மேல நம்பிக்கை இருந்தா கடவுள் கொடுத்திருந்தது இல்லை இயற்கை கொடுத்திருந்தது. கிருஷ்ணன் லென்ஸ். டிடெக்டர். What is the detector? தமிழ் ஒரு பழமொழி இருக்கு. கண் இருந்தும் குருடனாய், காது இருந்தும் செவிடனாய், நம்ம எல்லாம் படித்த முட்டாளாய். சொல்லி தலை குனிஞ்சிக்க நேரம் நின்று தான் சொல்ல, தைரியமா சொல்லு. எழுந்து சொல்லு பார்க்கலாம். சொல்லுங்க. Anybody have an answer?
Sir, what's your question?
Question புரியலையா?
Sir,
நம்ம எப்படி கண்ணால பாக்குறோம்?
Sir, rods and cones.
Micro?
Sir, rods and cones.
Rods and cones, okay. Rods and cones and rod, cylindrical rod, cones, conical shape. What is this material here? What you are saying is the shape of the material.
No,
I want
sir. Cell name.
Retina is the screen. Right. That is where the material is present. Right. Let me give you the answer. Please settle down. Settle down. It is called as the rhodopsin. It's an opsin. It's a chemistry molecule. Chemistry molecule. Yeah? It's an organic molecule. It is present in the shape of the rod shape of the protein. That is what is called the rhodopsin. Right? Rhodopsin. When the light is falling, what is happening? What is happening? How do you see it? There is a chemical reaction called as the isomerization reaction. Photoisomerization reaction. We have a beautiful detector in your body. It is sensing by photochemical reaction, photoisomerization reaction. How much time this reaction to take place?
1/16.
How much time? Nanosecond. யாராவது கரெக்டான ஆன்சர். எவ்வளவு நேரத்துல இந்த ஃபர்ஸ்ட் ரியாக்ஷன் நடக்குது?
1 by 16.
1 by 16.
Half a second.
What? 1 by 16? Length or meter or what?
Second of 1 second.
1 by 16 seconds. That's all. Okay. 1 by 16 is not a small number. Just 1 by 10 and 1 by 20. That's all. Nanosecond is how much time? 1 by 16. 1 by 16 is nanosecond, is that? Minus? 9. 10 power 9 is giga, yeah? 10 power? Minus 9. Very good. Minus 9. But it is much faster than that. It is happening in picoseconds. Minus 12 seconds. The primary photochemical reaction time scale is something like 100 picoseconds. Isomerization. You see that? Which is the very fastest detector in the world today. To tell you honestly, right, what you see on the earth, fastest detector is this. You don't have any other faster detector than this. Man-made detectors are only few closer to that, but this is much faster. You know why? It was not made by man. So you see the engineering behind it. Who is the engineer of this? That's what we believe. Right. There has to be an architect of this body. There is an architect, there is a scientist, there is an engineer. So many things involved in it. But even today, we have created so many engineers, so many scientists, they are not understood many things. Right? That is what is the curiosity you should build in yourself. Go for that kind of research. And that is very important thing. Right? So now detectors are very important. And you can also accelerate electron. Electron speed you can accelerate, right? So anybody has studied about accelerators? Inappa Tamil பேசணுமா? ரொம்ப சலசலப்பா இருக்குது இங்க. கொஞ்ச நேரம் டைம் லஞ்ச் டைம் இன்னும் ஆகல. இல்ல 1:45 1:45 லஞ்ச் டைமா? So 15 நிமிஷம் முன்னாடியே சொல்லிருக்கீங்க. Okay, 1 o'clock. You find the particle accelerators. So now you can accelerate linear accelerators. You have studied about cyclotron, like this. You can, how do you speed up it? Using the magnetic field, right? Magnetic field, because of the magnetism and electricity, one can drive the electron. உங்களை drive பண்ண எப்படி பண்றது? எலக்ட்ரானை டிரைவ் பண்றது ஈஸி. ஆனா உங்களை டிரைவ் பண்றது ரொம்ப கஷ்டம். ஏன்னா எலக்ட்ரான் மாஸ் ரொம்ப கம்மி, ஆனா நமக்கு மாஸ் ரொம்ப ஜாஸ்தி. நம்மளை டிரைவ் பண்றது அவ்வளவு ஈஸி இல்ல. யாரை விட்டே இருக்க மாட்டோம் அவ்வளவு சீக்கிரம். ரைட்? So that is the problem. Electron is so lighter, it is easy to drive. Right. Let's go to the photon. See the speed limit of photon. Photon. Right? So I have given in kilometers. 3 into 10 to the power of 10 meter per second or centimeter per second? 10 to the power of 8 meters per second. Very good. If you say in centimeters, 10. 3 into the 10 to the power of 10 centimeter per second. That is the speed that so far we know it. Many people have discovered or trying to invent or trying to estimate the speed of the light. And earlier it was measured in the year of 1676. They are not really that it is photon. They know there is a light. They are trying to measure the speed of the light. Fine. Many people have measured the speed of light. You know, I have given you a table. How many people have tried from 1676 onwards. Finally, some final value has been adopted. It's almost closer to 3 to the power of 10. Right? That is how there were error bars in all your measurements. They were trying to take the number 3 to the power of 10. Right? Many people also have a feeling light is always traveling through a medium. They call this like an ether medium. But later on, thank God, Einstein has given you the right answer. There is no such medium, no ether. It is traveling in vacuum also, right? And the speed of the light is the same in all directions. That also he has given you. And this is from the Michelson. And you should also know many cool things. the light is not hot. The light that you are getting from this, is it hot or cool? Hot. Light that you get from this is hot or cool? What light is that? White light. Very good. We call this like a tube light. Right? How many of you know this tube light? How it works? That is where the curiosity comes up. Phosphorus. Neon gas. Okay. So, do you know what is the color of the neon? Neon is not white light, yeah? It's color light. Argon is also color light. All inert gases give you color light. So, there is interesting behavior here. Let me give an answer here. Carefully listen. There is an electron also inside. Interestingly, there is an emission of electron. Where is the electron? You can see the two ends having a filament. What is the filament? Tungsten filament. You heat up tungsten, they emit electron. You see the source of electron is heating up any metal that you use it. Tungsten, they heat up, they emit electron. There is a gas inside. Basically, they use a low pressure mercury gas, mercury vapor. And the electron interacts with this gas, they excite the mercury atom. The electron is exciting the mercury atom goes to the higher energy level, they start emit light. Right? Right? So they emit radiation, right? And they have a radiation emission coming up from the excited state atom, and they excite the molecules or materials coated on the inner surface of the tube light, and that is basically inorganic phosphors. Inorganic phosphors are a mixture of zinc oxide and mercury oxide there, right? And they emit white light. So there is an electron exciting the gaseous form of the mercury. In turn, they excite your inorganic phosphors. You get a white light, cool light. That is what I say. The cool thing to know about light. What are the cool things light refracts? Light beautifully refracts. We have already studied about refraction, refractive index. We also know refractive index of the medium, and this is how the refractive index helps you to focus your light. Put a lens in front of the light. Refraction always helps you to focus the light, and it also dispersion. Dispersion is possible. When you put a prism, you can convert, otherwise separate the white color into its components. With GR you always say, and that is what is your colored light. Reflection, they also reflect, right? And you also have the internal reflection. It is a total internal reflection is possible, and these all putting together you can have a beautiful phenomenon happening is rainbow. Rainbow is happening because of the total internal reflection. Fine? And you also see that another interesting aspect is diffraction. Diffraction, right? They diffract. These are basically the properties we know in the wave nature of the light. And these properties are very important, and they diffract. They also create interference patterns. You can do a double slit experiment, do an interference pattern. You can have a constructive interference and destructive interference, right? You can have the crest and troughs, you can have it, and you have the interference pattern. Fine. It means this, right? So light we can say, based on this, is a wave nature. Wave nature. You have a wavelength. You have beautiful wavelength coming up for the light, and lambda is equal to c by u. So the frequency, speed of light, and wavelength. Right. So wave you can see the crest and troughs. Right. So this is about the cool things about light. Now you also see that Take a stock of this. Max Planck gave in 1900s, and he was the guy who was really talking about particle nature. Slowly it was confirmed, and it was further confirmed by Albert Einstein. For your information, what is the first invention of Albert Einstein?
On light quanta.
Light quanta is second one. Black body is also the second one. This is all light quanta is coming from black body experiment.
Special relative.
E is equal to mc squared. Relativity theory. Relativity theory, I'm giving you the answer. But for that you didn't get the Nobel Prize. He got the Nobel Prize for the black body, otherwise for quantum effect of the light that you have seen it, right? So later on, Planck has given you the law and giving you about spontaneous radiation and induced radiation. 1920s, you had a quantum effect, which is where you can talk about photons and deep Bragg relationship, uncertainty principle, Schrödinger, talking about energy expression. Finally, the quantization. Quantum mechanics told all about the atoms, but if you look at the Dirac, it has given you about quantum electrodynamics. This is how the light, the people have worked on the basic science of light, right? They have given you a lot of ideas what is light. Now, what is light? What is electron? Electron, if you summarize it, it is negatively charged, the mass is very less, and it is having the momentum, right? It can be accelerated. But look at the photon. Photon is also dual nature, as you see in the case of electron, but it does not have the momentum. It is not negatively charged. It cannot be accelerated. It is always traveling with the constant speed. You can slow down the light. Refraction. So why do you think the refraction phenomenon is happening? You can slow down the light. How do you slow down?
By traveling from one medium.
Right. Why one medium to another medium?
It is denser.
Denser medium. Optically denser medium? No. Light should not be absorbed there. It is not it is optically transparent medium. It is not optically denser medium. It is traveling from a denser, lighter medium to a denser medium. Why light has to refract? Why light has to refract? Do you have an answer for that? Have you ever, why speed has to slow down? What interaction? That is how the question goes. That is where science is going. What obstacle? If I want to pass through gap between you, it is difficult for me to pass through, right? Light has to take a dilly-dallying routes.
Speed of light is
How? Who is the disturbance? Changing medium, why? It's traveling in a straight path, yes, like this. Right, what you are saying is right. But the real answer is, there is an interaction between light. Now, which part of the light? When I define light, it has the electric vector and the magnetic vector. That is what we call it like an electromagnetic radiation. Now, you have the electric vector that is trying to interact with the material. What is the material? It is a denser medium, for example, glass. Glass that you are using it. What is it made of? Silica. Right. It's again another soil. Another form of the soil. Silicate structure. Not exactly silica, it's a silicate structure. Silicon, oxygen, silicon, oxygen. You can see the electronegativity difference. There is a dipole. Light is a dipole. There is a dipole-dipole interaction. Attraction, repulsion makes it to slow down when it goes into the denser medium. That is what is really happening in the refraction when the light is interacting with the materials. You can see now the electromagnetic radiation, whole gamut of light that you are getting in, it starts from radio frequency to gamma rays. So what is radio frequency? Energy, see, that's the lowest energy you can carry. And highest energy you can carry is gamma rays. And in between you have an interesting energy source, visible, infrared, ultraviolet, and you also have the visible region, visible, ultraviolet, infrared. Now what is the source of this region? What is the source for this, do you think? And each one, if you look at it, shorter wavelength, you can study about atomic, nuclei, atom, proteins, virus. Here you can talk about the interaction of the matter with light, right? And you can slowly see it, many interactions. We also use a microwave for communication, radio frequency for transistors and radio waves, right? So many frequencies we use it. But there is one light source for the visible, IR, and ultraviolet radiation. Which source do you think? No answer? God's Son. Nobody else. A beautiful God's Son. Right? He is the source of the light. And what kind of light you get? Again, electromagnetic radiation. It's the electric vector and the magnetic vector. Now, what is the region of light that you get out of the sun? You can see that starting from ultraviolet, going up to infrared radiation, right? Infrared radiation, you can see it, mostly water absorbed here, and you can see they are dense, intensity is very high around the blue region, 450 nanometers, you get the very huge intensity of light from the sun. That is where you can see it, your natural systems are absorbing light. You see it? So, the sun, the plant kingdom has a correlation. They have a communication. They communicate very well. Why plants have to be green? Well, why not it is red? Why not it is blue? Who has divided it to become green? Chlorophyll. Who has created chlorophyll? That is what is the nature. And if there is a correlation, the light is being absorbed in this region. Beautifully, it absorbs in the blue region. Right? So the blue color material absorbing blue. It's a complementary colors, you should know it. They are